Okay, so let's look at our experiment for this week, which pertains to Newton's second law. And let's walk through this document, which can be found under course content. Let me back up just a little bit just to make sure that we're on the same page here. So there was a document in here, if you're looking at this in spring of 2023, and you may have gotten a little ahead of me because I'm working about a day behind and getting this out to you. I try to get this out to you early, but I'm running about 2 days late because I had to convert a document into a PDF. So my apologies. Due date, you still have a week to do this in groups, so no time lost there. So in case you wanted that extra 2 days, my apologies. So you'll want to download this, or open up this and then download it. This is the old version here. So let me change that real quick. So version. And then the information is still good, but it's more of a Word document. And I thought the fillable PDF would be a little bit more user friendly. So you're going to want to open and download this, and then reopen it in Adobe Reader, Adobe Pro, whatever Adobe instrument you have. So you're going to want to use this download button. The download button embedded here, for some reason, does not download to the way we want it to open. So I have to do this like twice over because my browser automatically wants to open it up in itself. So let me kind of back out of that real quick. And let's see, this one's sometimes a little tricky. I'll have to go to the document itself one more time. So of course, content, I have to go to the folder in which it resides. So you download it from this. I have to show it in the folder in which it resides. And then I can download this, and my computer should then open it up in Adobe Reader. So now you can see around here, around the border, the Adobe tools are there. So if you have Adobe Reader, that's fine. It should work just perfectly. So most of this is pretty much self-explanatory, and it's kind of similar to what you had in that Word document, except I put some PDFs so that it's a little bit cleaner on my end when I see things, and you guys have a way of seeing how to put this in table form. So for the first experiment, what you're going to want to do is you're going to want to go to this simulation here. It is hot link, but it's not underlined. And it will take you to the simulation that says acceleration. So you want to click on that little sub simulation there. And let me open up and split the screen here with both of these pieces so we can kind of follow along. So in a nutshell, what we're going to want to do is we're going to want to select these main 5 check boxes, and then you're going to want to select this so that the friction is 0. Okay, so you'll read through this and you'll see how this all works. And so the first time around, what you're going to want to do is you're going to want to fill in this table. And in case you're not sure, I give you some hints. On this, in this first cell here, you want to put in some the proper units. So won't give you the answer, but I think you can probably figure out what it is. All right. Well, that one probably should be that. And this one might be, I'll just say, misspelled intentionally. And again, misspelled intentionally. Okay. So you're going to want to put in the numeric value. So the first time around, you're going to keep the mass constant. So let's just say that you have something, and I'll say, just to make things a little interesting, something of 250 kilograms. So we're going to keep this a constant 250 kilograms. To get 250 kilograms, we'll just sum those up. And then make sure a couple things, we want friction to be gone away. So we want that surface to look like ice. And you're going to want that little man to stay in contact with the object or objects in this situation, right? Pay attention to the acceleration that's right above his head to the left. Right, so that's why we put that in. And there's a couple ways you can apply force. You can apply force using these little double arrows here, which increment by 50, or you can hit this little single arrow, which increments by 1. So it's up to you, however you want to do this. You might want to see a little bit more tighter, denser values. I would suggest that you kind of space them out. And then you're going to want to lock down on what that acceleration is. Now, this thing is accelerating, which means that the speed is constantly increasing. And so what's going to happen after a while, once this thing reaches 40 meters per second, the man will release himself, will fall off the box. So this only has so much information that it could store. And so there's a couple of things, play around with it, but you can make them go the other direction as well. So you can send them the opposite direction, and you can see what the acceleration is in that instance. Right. So play around with that. That's what this is all about. This is experimentation. And then you're going to graph what you get. So there's you're going to want to graph in slope-intercept form in that little area. Acceleration versus net force. And you're going to want to make sure you label the axes appropriately. And so to label appropriately, what I mean is x-axis should represent some value if we're dealing, or values if we're dealing with, let's say in this case, force and acceleration. So again, you're going to want to play around with that. You want to look at that carefully to see if it makes sense, and gather up some information about specifically the slope. Okay, and that should kind of give you an idea of what you're kind of hunting for, because you're going to see this type of experiment down the line. Okay, so in the second experiment, we're going to use the same simulation, except this time we set the net force to be constant. So remember in that last experiment number 1, what you should be doing is you should be changing these masses and figuring out the acceleration. In this case, you're going to set the force to be constant. Sorry, let me back up. In the last experiment, you were to set the mass to be constant. So we only played around with a 250 kilogram source or object, and we change the net force each time. So maybe 123, 100 or 203, so on and so forth. We can do it by either grabbing him or using these double arrows. So in experiment number 2, what we're going to do is we're going to keep the same net force, but we're going to vary the mass. So this is where you're going to want to use this little double arrow here. Okay. And so you can change the mass. You're going to note what the acceleration is over here. You're going to put in the proper units. And by putting in these proper units here, what I'm trying to get you to understand is once you define what your units are for this column, everything, the numeric values all are in line with those units. So let's just say you got 0.75 meters per second squared. You don't need to write 0.75 meters per second squared. This column heading takes over, and it's assumed that everything below it are in the same units. Okay. The 1 over acceleration, basically what you're going to do is you're going to flip the units and flip the numeric value as well. So if you got 0.75, which is basically 75 over 100, you're going to flip the numeric value, so 100 over 75. Remember to flip the units as well. Meters per second squared becomes second squared over meters. And you're going to also graph that, right? So you're going to want to graph 1 over the acceleration versus mass. And you should be able to see something there. That graph you're going to upload and place it in here. You probably want to use Excel or whatever tool you use. Just make sure that it is neat. All right, and then the last experiment, what you're going to do is you're going to go to this this final simulation, which is a little bit old schoolish, if you will. Click on that hot link there, see if it takes us. Yeah, so it's loading over here. So let's see if it works. A second ago, it crashed on me. So yeah, there we go. And so you're going to want to run this ChairPJ browser compatible version. That seems to work out the best. It's a little antiquated, but it works, and it has some pretty good features associated with it. Takes a few seconds to load up here. And the reason why this one uses this, the reason I use it is because it, like I said, gives us a lot of good information from looking at the simulation, and simultaneously we're going to generate some charts and graphs here. But it also has a record feature to it. So in case it goes a little bit too fast, you can go back and you can kind of replay what you think you saw. Okay. And so let me move that out the way. I have it over here. I'm going to slide that over for you here in just a second. So here is our new simulation. And I need to move some of this stuff over because it tends to crash. So you're not seeing the document anymore. You should only be seeing the man with the box here. And so what we're going to do is we are going to, yeah, we're fine. We're going to select this tab that says force graphs here, and we're going to notice that we generate this little graph down below. Now, also what you want to do is you probably want to select this plus button so you can see the acceleration at the same time. Now, what possessed them to use green lettering as a background, which makes it kind of hard to see. I'm not sure why they did that. But in any case, we're going to want to apply some force. So you can apply forces specific ways. So the first thing you're going to probably want to do is kind of play around with this and grab this little arrow here. You can see that I'm applying a force, but it looks like about 200 newtons, but the object is not moving, right? The file cabinet is not moving. So it doesn't start to move until it gets to about, let's see here, whoops, like this. So start to push, and then it starts to move at some point. So what you'll start to notice here, let's see if I can get this to stop. You start to notice, I'm going to push the other direction, reset this. You can reposition this over here using that arrow. What you'll see is the sum of a couple of arrows here. So this is the force of friction, which points opposite. F of A is considered the applied force. We have the force of gravity, which is weight. And you have the normal force pointing in the opposite direction. And so what you could do is you can show the free body diagram, because the weight or the force of gravity is moving a little bit or is being hindered by this graph here. You can do that, and you can play it back to see exactly when this thing began to move. So this is when I was having a little bit of issue, and then right there, you can see it just begin to move. Now you can also see when it begins to move by seeing when the position changed. So right about here at this point is when this thing began to move. You can slow it up a little bit. I think you can rewind it, but at least it gives you some idea, and then play it back a couple times so you can see, what happened. So that's a nice feature. All right, and then you're going to see this little chart in our report that you need to fill out as well. And so don't worry about the red, the red around it. This is sort of a project that I've been working on here for the last couple of days. But for the first column here, what you're going to want to do is you're going to want to put in the proper unit. So let's just say that the textbook has a specific mass to it. Let me show you where to find that. So on the simulation, if you do this little drop down arrow, you'll see this textbook here, and you'll see the mass, you'll see the coefficient of kinetic friction, and use of S, which is the coefficient of static friction. And so you're going to want to put that in the boxes in this chart, and you're going to want to plug in the information that you find from the simulation. And so I think that was 10 kilograms. So you want to type that in for this column here. So this column, I'm not asking for specific units, even though they should all be in SI units. So you're going to want to fill this in. And each one of these here, you will. Now, in some of the tabs, I've put in, little hints as to what I'm looking for, but it's a little bit cumbersome to do it for every one of these cells. So you may not see it, but it's somewhat self-explanatory. Notice that there is not one here for the units. Coefficient of static friction as well as kinetic friction is a unitless number. So you're going to just want to plug in some number in here. Okay. And it should be fairly small, so you shouldn't have to worry about it overflowing in that area. That's another thing that you have to do in terms of building these tables. All right, then also you're going to want to draw that free body diagram. Make sure that you label the forces with the appropriate names, and make sure that you upload it. You can upload this into your from your phone or from your computer. Most of you guys already know how to upload, because you already upload into the My Courses show, which you'll have to do here. So uploading a picture is fairly easy. So if you have any questions about that, just give me a call or send me an email. Okay, I don't want to make this explanation too long. If you have any questions, please feel free to give me a call or send me an email. All right, take care.